Bob and Hi. So today our group will presenting a modeling of a spring mesh systems and its applications. Uh, a spring mesh system is an example of a simple harmonic motion, which is a type of periodic motion that occurs when the restoring force is proportional to the displacement from equilibrium, and we will be focusing on the mathematical modeling of a spring mesh system, which is involve the second order differential equation that represent force or them simple harmonic motions. To introduce our lecturer that help us through this journey, which is Dr. Rasmila binti Abdul Kahar. And my partner in doing this assignment is Nurabila binti Mansur with metric number AW210096, and me, myself, Narashikin Zulaika binti Yulkifli with metric number AW210080. For the slide content, first we will have introduction, which will describe the differential equation, the ordinary differential equations, and the applications of second order. Is a problem statement, objective, which we will solve the problem that we have stated at the problem statements. Method, which we will have three methods to solve the problems on the modeling spring systems. Next is about the result and the discussions. The result that we obtain after solving the problems, and the discussion that we achieve from the objective. Conclusions, where we have concluded what we have obtained and learned from doing this, from solving this application of modeling spring systems. Okay, first we will go through the introductions. The first point is ODE is the short form for ordinary differential equations, which is a mathematical equations that describe the relationship between a function and its derivatives. ODE involve only one independent variable and can be classified according to the order. The simplest ODE are first order ODE, first order ordinary differential equation, which is involve only the first derivative, and for second order ordinary differential equation, it involves the second derivative and are used to model various real-world phenomena such as the motion of a spring mesh system. There are various methods that can be used to solve the ODE, such as separation of variables, Laplace transforms, or any other numerical methods. Next is problem statement, where we have found four main problems that related to the modeling of a spring mesh systems. Problem statement. The first problem is find the displacement of the mesh from its equilibrium position as a function over time given the mass and spring constants. To find the displacement of a mass from its equilibrium position as a function of a time, we need to know the initial conditions of the system, such as the initial displacements and the velocity of the mass. And then the equations of motion for a spring system is given by the m mass times the second derivative of x with respect to the t plus k times x equals to 0. For this, we will describe more in the application part. Next is determine the period, determine the period and frequency of the motions of the spring mass systems. It is the important aspect of understanding the behavior of the systems. There are a few steps that can be used to determine the period and frequency of the motion of a spring systems. First, we can first we need to identify the mass, and we can use the equations to find the period of the motions, and we can use another equation to find the frequency. It is important to note that the period and the frequency of spring mass systems are inversely related. The highest frequency will have the shortest periods. Both springs have the same mass on the spring constants. Its difference. A spring with a higher spring constant will have a shorter period. Kalau macam kalau macam semakin tinggi frekuensi tu, dia akan semakin rendah dia punya period. So, frekuensi adalah inversely proportional to the period. The period and the frequency of a mass on a spring can be found using the equations of motions and Newton's second law. The position, velocity, and acceleration can be found for any time. Dia penting untuk kita ingat, kita penting untuk guna equations ni. Kalau macam kita guna equation ni, kita punya calculator kena dalam mode radian. So, the period and frequency of a spring mass system ni, dia boleh determine by identify bila kita dah tahu the mass and spring constant of the system. Gunakan equation yang 2 pi mkn, itulah equation yang tadi tu. Dan macam tadilah, period and frequency adalah inversely proportional. Next is to investigate the effect of damping on the motions of the spring system by solving a second-order differential equation representing them simple harmonic motions. To solve this differential equation, we can assume that the displacement of the mass is given by x of t equals a times e to the power of negative gamma t times cosine of omega d times plus pi, where a is the amplitude of the motion, gamma is the damping ratio, omega is the damped natural frequency, and the pi is the phase angles. The effect of damping on the motion of the spring system, dia help to reduce the amplitude of the motions over time. The damping ratio, gamma, determines the rate of which of the amplitude decrease. If gamma is small, then the systems will oscillate for a long time before coming to rest. If gamma is large, the system will quickly come to rest. The damped natural frequency omega is also affected by damping and is always less than the natural frequency of the undamped systems. And the last one is to investigate the effect of an external force on the motion of a spring system. We need to solve a second-order differential equation that represents 4 simple harmonic motions, which is the equations which by using the given equation. To solve the differential equation, kita boleh assume yang displacement of the mass is given by x of t equals x of omega 0 gamma omega, where x is the amplitude of the motions, omega is 0 is the natural frequency of the systems, gamma is the damping ratio, and omega is the frequency of the external force. The effect of an external force on the motion on the motion of the spring system is to cause the system to oscillate with a frequency that is different from the natural frequencies of the system. The amplitude of the motions will depend amplitude dia akan depend dengan frequency of the external force. And dia akan depend juga dengan damping ratio of the system. So, kalau macam frequency external force dia close to the natural frequency of the system, the amplitude dia akan lagi tinggi lah. Tapi if the damping ratio is large, the amplitude of the motion will decrease quickly. So diorang ni inverse antara damping dengan amplitude. Kalau damping tinggi, amplitude akan rendah. To go through the objective that we can use to solve the problems I just talked. First, we have to understand the concept of second order ordinary differential equations and their applications in modeling the motion of a spring system. And the second one is able to model the motion of a spring mass system using a second order ODE and solve the problems. For example, finding the displacement, period, and the frequency of the motions. And the last one is to investigate the effect of damping and external forces on the motion of the spring mass system by solving the second order differential equations that representing them and for simple harmonic motions.
Now we move to the method of the modeling spring mass system, which has 3 steps here. We can see step 1, the force acting on the mass. Step 2, apply Newton's second law. And step 3, solve the differential equation. So step first, which has force due the spring, which is proportional to the displacement x and given by k negative kx. Then force due to the any external factor which we denote by F external. For the step 2, we apply the Newton's second law. So here is the equation of differential equation. A second order linear ordinary differential equation with constant coefficient. So for the step 3, we assume a solution of the form xt equal ae exponent rt. So where a is a constant and r is a complex number. So then we substitute into the differential equation. We get mr squared plus k equal to 0. By solving this, we want to get r. So we get plus minus square root k over m. So then for the general solution to the differential equation is given by xt equals c1 cos omega t plus c2 sin omega t plus f external over k, where omega we got square root k over m is a natural frequency of the system, and c1 c2 is a constant to determine by initial condition. Now we move to result and discussion, which has 3 results and 3 discussion. First, a spring mass system is a physical system that consists of a mass attached to a spring. Then the equation of motion for the system can be solved by using various methods such as separation of variable, Laplace transform, and numerical method. For the second, the solution to the ODE gives us the displacement of the object as a function of time. So, problem related to the spring mass system include finding the displacement, period, frequency of motion, investigating the effect of damping and external force, also determining the energy of the system. Okay, for the third result, the spring mesh system is used to model various real-world phenomena such as the motion of car, kereta bergerak, and then suspension system, then the oscillation of a pendulum, and then the motion of mass attached to the spring in a vertical or horizontal direction. A spring mass system also used in engineering and physics, such as vibration, as we learn in nuclear modern physics, wave, as we learn, and optic and wave and oscillation. And lastly, for conclusion, first objective for conclusion, provide a foundation for solving problems related to the motion of a spring mass system. And understanding, we can understand the model of the motion of a spring mass system using a second order ODE and solve related problem by displacement of the motion, period of the motion, frequency of the motion. For the second objective is allow us to understand how damping and external force affect the motion of the spring mass system by solving differential equation represent damp and force simple harmonic motion. So we can solve real world problem related to the motion spring mass system. And lastly, the third objective allow us to solve real world problem related to the motion of a spring mass system by using mathematical method. That's all from us. Thank you.